Let us continue our discussion on the chapter of polynomials. And if you recall, in the previous lecture, we had studied about the factorization of quadratic polynomials. What are quadratic polynomials? Polynomials which have a degree of 2 are called as quadratic polynomials. That means the highest power for the variable is 2. In that case, we call it as a quadratic polynomial. And we saw in the previous class the method of factorization by splitting the middle term. And today we are going to look at how to factorize cubic polynomials. And cubic polynomials have a degree of 3. That means the highest power of the variable is 3. So it is having a degree of 3. And a polynomial with degree 3 is called as a cubic polynomial. So we will see today how to factorize a cubic polynomial. And the first step that we have to do in factorizing the cubic polynomial is to find the zero of the polynomial. And what is the zero of the polynomial? It is the value of x, which when substituted into the polynomial expression, the polynomial should evaluate to 0. So we'll have to find out by trial what number for x or what value of x will make this entire polynomial go to 0 when we substitute that value into this expression. So the only way to do that is to use a trial and error method. But the one hint that we can get is whatever is the root will be a factor of this last constant term, which is minus 120. So we need to look at all possible factors of minus 120. So in this case, plus or minus 1 is a factor of minus 120. Similarly, plus or minus 2 and plus or minus 3, all these are, and plus or minus 4, plus or minus 6, plus or minus 5 as well. So there are many factors of minus 120. So generally for class 9 problems, it will usually be the case that either plus 1 or minus 1 or plus 2 or minus 2 would be 0 of the polynomial. So we have to start with the smaller numbers close to 0, plus or minus 1 or plus or minus 2, and substitute in the expression and see if it evaluates to 0. So that will give us the zero of the polynomial. If we know one zero of the polynomial, we can get one factor of the polynomial, and then we can proceed further into subsequent factorization. So let's try x equals minus 1. Okay, x equals minus 1. So if we put x equal to minus 1, we will get p of minus 1, and when we substitute minus 1 in this expression, we will get minus 1 cube minus 23 into minus 1 square plus 142 into minus 1 minus 120. And what does this evaluate to? So this will give us minus 1 power 3 is minus 1. Minus 23 into minus 1 square is plus 1. So minus 23 into plus 1 will remain minus 23. So it's minus 23. 142 into minus 1 is minus 142 and minus 120. So we have minus 142, minus 50. All the numbers are minus. So it will be minus something, and of course that is not equal to 0. So minus 1 is not a 0 of the polynomial. So let us check x equal to 1. So we will find p of 1. So that will give us 1 cube, so it's x cube minus 23 into 1 square plus 142 into 1 minus 120. So we have 1 cube is 1, minus 23 into 1 square is 1, so minus 23 into 1 is minus 23. 142 into plus 1 is plus 142, and we have minus 120. So 1 minus 23 is minus 22. So that's minus 22 plus 142 minus 120. So 142 minus 22 is 120 minus 120. So this evaluates to 0. So since this is 0, since x equal to 1 is a 0 of the polynomial, therefore we can say x minus 1 is a factor of this p of x. Okay, so I'm not going to write the expression for the p of x. Okay, p of x equals this. So x minus 1 is one of the factors of this polynomial. So we need to now find the remaining factors of this polynomial, and what we have to do for that is, once we have found 0, which is x equal to 1 in this case, we have to perform synthetic division, or basically we are going to divide the polynomial p of x by one of the factors to get the other factor, and then we can subsequently factorize the other factor if it is having a degree 2 or more. Okay, so let's see how we can divide. A simple way of dividing the polynomial by the one factor that we have found out already is by using synthetic division. So what is synthetic division? So basically we are going to write the coefficients of the given polynomial. So we have I'll do the synthetic division on the right hand side here. So we have x cube minus 23x square plus 142x minus 120. So what we do is we take the coefficients of each of the terms. For x cube, the coefficient of x cube is 1. It is 1x cube, so we write that 1. For x squared, the coefficient is minus 23. For x, the coefficient is plus 142, and the constant term is minus 120. So we have this, and we are going to do synthetic division by using the 0 of the polynomial that we have already found. So we have found that x equal to 1 is a 0 of this polynomial, so we'll divide it by 1. Okay, so what we do is in synthetic division, so for the first term we'll just put a 0 here and then add these two terms. So 1 plus 0 is 1. Now what we do is what we have outside here, that will multiply the one that we have here. So 1 into 1 is 1. So we write that product over here in the next position. So now we add these two terms which are here, minus 23 plus 1. So minus 23 plus 1 is going to give us minus 22. Now we are going to multiply this minus 22 with the one that is here. So minus 22 into 1 is minus 22. So we'll put that minus 22 in the next position here, and then add these two terms. So 142 minus 22. So that gives us 142 minus 22 is 120. And then again we will multiply this 120 with this one here. So 120 into 1 is again plus 120. So now when we add these last column terms, minus 120 plus 120 is 0. So this will go off. Okay, so now what we have is 1 minus 22 and 120. So now since we are already dividing by this factor, these will have these are the coefficients of the polynomial whose degree will be 1 less than the given polynomial. So our polynomial is having a degree 3, and this will represent a polynomial whose degree is 1 less than 3, which is 2. So this 1 denotes the coefficient of x square. So it will be x square, and this 22 or minus 22 denotes the coefficient of x. So that will be minus 22x. And this denotes the constant coefficient, which is plus 120. So now we have a polynomial whose degree is 1 less than the degree of our given polynomial. So our given polynomial has a degree of 3, and from these numbers we get the coefficients of the other polynomial whose degree is 1 less than the given polynomial's degree. So now this is also a factor of our given polynomial. So x minus 1 is one factor, and the second factor is x squared minus 22x plus 120. So our p of x now can be written as, let me write that here. So therefore we can write p of x, which is equal to x cube minus 23x squared plus 142x minus 120, and we can write this as a product of its factors. So one of the factor is x minus 1 and the other factor is this x square minus 22x plus 120. So we can write it as x minus 1 into x square minus 22x plus 120. So now we have written it as a product of its factors. But again, the second factor that we have here, it's a quadratic polynomial, which we can split further by finding its own factors. So we can use the method of splitting the middle term to factorize this quadratic term further, and then we will have the final factors of the cubic polynomial. So we can further factorize this quadratic polynomial, and we will see what we get for the final factors for our given cubic polynomial. So I'll write this whole expression again on the next page and proceed with factorizing the quadratic polynomial. So I will rewrite the whole thing here. So I've just rewritten the entire thing here on this new page. So we have our p of x, which is a cubic polynomial, as a product of its two factors. So what we are going to do next is we are going to factorize our quadratic polynomial here. Okay, this one we will factorize further, and then we will rewrite the whole set of factors for the cubic polynomial. So now I'm going to do the quadratic polynomial separately here. So we will have x square minus 22x plus 120. So we have to use the method of splitting the middle term. So we have to split the middle term such that the product is 120. Okay, the product of the two numbers that we use in splitting should be a into c, the coefficient of x square multiplied with the constant term, so which is its coefficient of x square is 1 into 120 is 120. So we have 120 to be the product, and when we add the two terms we should get minus 22. So we have to choose two numbers such that their product is plus 120 and their sum is minus 22. So what are the two numbers that we can choose? Clearly one of the combinations for 120 product, which will give us a sum of minus 22, is 12 and 10. So we can use 12 and 10, and when we add them we will get 22, but we want minus 22, so we can put a minus in front of both the numbers. So minus 12 minus 10 is minus 22, and the product minus 12 into minus 10 is plus 120, because both are minus. Minus into minus will become plus, and 12 into 10 is 120, and minus 12 minus 10 is minus 22. So we can split this middle term in terms of these two numbers, which is minus 12 and minus 10. So we can write this as x square minus 12x minus 10x plus 120. Okay, so let me separate this. Okay, how we have got the splitting of the middle term, and now we can simplify this expression further. So we can take x as a common factor, and we have x minus 12. Okay, so we have x into x, that will give us x square, and minus 12, so x into minus 12 will give us minus 12x. So now we can simply replicate this x minus 12 term, so x minus 12 here. So with what number, if we multiply x minus 12, we will get the second half of this polynomial, and that is clearly minus 10. So minus 10 into x is minus 10x, and minus 10 into minus 12 will give us plus 120. So now we can take the x minus 12 as a common factor, so that will give us x minus 12 into x minus 10. So we now have split the quadratic part, okay, this particular factor, the quadratic factor, into further two factors of degree 1. So we can rewrite this as, so this is equal to x minus 1 into x minus 12 into x minus 10. So the complete set of factors for our given cubic polynomial are x minus 1, x minus 12, and x minus 10. So overall, we can write our p of x equals x cubed minus 23 x square plus 142 x minus 120 in terms of the product of its factors as x minus 1 into x minus 12 into x minus 10. Okay, so that's the factorization which is completed now. So the procedure for factorizing a cubic polynomial is to first find one of the zeros of the polynomial by trial. We have to do that by trial and error, so we have to keep trying different numbers. We have no other choice, but one hint we can get is from the constant term here. The zero of the polynomial would be a factor of this constant term. Generally, for your case, for your class, you can try with the numbers like 1 minus 1 or 2 minus 2. Usually you will find a 0 within these numbers, either 1 or minus 1 or 2 or minus 2 and so on. So once you find one of the zeros, you can find one factor of that polynomial, and then using that 0 we can perform synthetic division to find the other factor. Okay, and when you're performing synthetic division, what you have to remember is that we'll use that 0, which is 1, the 0 of the polynomial, which is the value of x at which it evaluates to 0, to divide the coefficients of the given cubic polynomial. So this 1 here is the coefficient of x cubed, minus 23 is the coefficient of x squared, plus 142 is the coefficient of x, and minus 120 is the constant term. Okay, so then what we do is we put a 0 here, okay, in the first step, and then add these two numbers. So 1 plus 0 is 1, then multiply this 1 with the term that we are dividing with. So 1 into 1 is 1. Then add these two terms, you get minus 22. Multiply this minus 22 with this 1. So you get minus 22 into 1 is minus 22. Add these two terms, you get this 120. And then multiply again with the 1 and add these terms, you get 0. So now these numbers, the non-zero numbers that we have here, they represent the coefficients of the polynomial whose degree will be 1 less than the given cubic polynomial. So cubic polynomial is having a degree of 3, so this will have a degree of 2. So the highest power is 2. So the first term here represents or denotes the coefficient of the term with x squared, the degree 2 or the power 2. Minus 22 is the coefficient of x, and 120 is the coefficient of x power 0 or the constant term. Okay, so once we have this, we can write our given polynomial as a product of the first factor, and this will be our second factor. Then we have proceeded further by factorizing the second term, which is a quadratic polynomial. So we can use either the factor theorem, or by splitting the middle term we can factorize this quadratic polynomial as well. And once we have factorized that, we get all the factors of the given cubic polynomial. Okay, so I hope it's clear here. And just to emphasize and practice this procedure, let us do some of the exercise problems from exercise 2.3 in the textbook. There are 4 questions given, and in this video we will solve all the 4 questions so that we have a clear understanding of how to factorize cubic polynomials. So let us now solve this first problem from the exercise. We have a cubic polynomial x cubed minus 2x squared minus x plus 2. So the first step is to find the one of the zeros of this polynomial by trial. So let x equals 1, and we see what is p of 1. Now let me write that properly. So p of 1, so we have to substitute 1 in the expression. So it's 1 cubed minus 2 into 1 square minus 1 plus 2. So that's 1 cube is 1, minus 2 into 1 square is minus 2, minus 1 plus 2. So we have 1 and minus 1 cancelling out, minus 2 and plus 2 cancelling out. So that evaluates to 0. So x equal to 1 is one of the zeros of the polynomials. So therefore we will have x minus 1 is a factor of this p of x. So next step is synthetic division. So let me write that. Synthetic division. So what we do is we take our given cubic polynomial and write its coefficients. So the coefficient of x power 3 is 1. So we'll write that. The coefficient of x square is minus 2. The coefficient of x is minus 1 because we have minus x. That means it's minus 1x. So the coefficient of x is minus 1. And the constant term is 2. And we are going to perform synthetic division by using this factor. So x minus 1 is a factor, therefore x equal to 1 is a 0 of this polynomial. So we'll use that x equal to 1 as the dividing term. So the first step is we'll just put 0 below the first term here. So and add those terms. So 1 plus 0 we get 1. And we multiply this 1 with this 1. So 1 into 1 we get 1, which we'll put in the next position. Then we add these two terms. So minus 2 plus 1 will give us minus 1. Now we multiply this minus 1 and this plus 1. So minus 1 into plus 1 is minus 1. And then again we add these two terms. So minus 1 will give us minus 2. And now we multiply minus 2 with this term. So minus 2 into 1 is minus 2. And then we add these two terms. So 2 minus 2 we get 0. So these are the numbers at the bottom that we have here. These are the coefficients of a polynomial whose degree will be 1 less than the degree of our given polynomial. So basically this is going to be 1x squared minus 1x minus 2. So it's x squared minus x minus 2. So we can now write our given polynomial as p of x. We have one factor is x minus 1 and the other factor is x squared minus x minus 2. So we can write our p of x equals x cubed minus 2x squared minus x plus 2 in terms of its factors, which is x minus 1 into x squared minus x minus 2. Okay, so now we have these factors. What we can further do now is we have the second factor, which is a quadratic factor, okay, a quadratic polynomial. So we can factorize this further and find its own factors. So that way we will have all the factors of our given cubic polynomial. So I'll continue that on the next page. So we can write our p of x as, okay, so I'll just read it in this whole thing again here. So our p of x, which is a cubic polynomial, has these two factors, x minus 1 and this quadratic factor, x squared minus x minus 2. So we will now split this x squared minus x minus 2 into its own factors. So let's do that separately on this side of the page. So we have x squared minus x minus 2. So what we have to do is we need to find, or we need to split the middle term minus this minus x, or which is minus 1x, such that when we add the two terms we should get minus x, and when we multiply the two terms we should get minus 2, because the product is going to be the coefficient a into c, ax squared plus bx plus c, right? So a is plus 1 and c is minus 2. So 1 into minus 2 will be minus 2. So we have to split it such that we get a product of minus 2 and the sum should be minus 1. So what are the two numbers that we can use such that their product becomes minus 2 and their sum is minus 1? So the product of two numbers that will give a value of 2 is simply going to be 2 into 1, 2. Okay, so 2 into 1 will give us 2, but we want minus 2. So we have to put a minus in front of one of these numbers. So we can either put a minus in front of the 2. So it will be minus 2 into plus 1, which is minus 2. And minus 2 plus 1 will get minus 1. If we put a minus negative sign in front of the 1 instead of the 2, then we'll have 2 into minus 1 as minus 2, which will be correct. But 2 minus 1 will give us plus 1. But we need a minus 1 here. So we'll put the negative sign in front of the bigger of these two numbers. So we'll put the minus in front of this 2. So now we have the correct way of splitting. So minus 2 into 1 is minus 2, and minus 2 plus 1 is minus 1. So we can now split this as x square minus 2x plus x minus 2. So clearly now the equation does not change, okay, so the expression does not change. So we have in place of x square, minus 2x plus x is minus x, and we have the minus 2 term as well. So now we can just take x as a common factor. So taking x as the common factor, so x into x minus 2, and then we have this x minus 2 repeating itself. So now we have to find a number outside this bracket, which when multiplied with this x minus 2 gives us this second half of the polynomial. So that number clearly is going to be plus 1, because when we multiply plus 1 into x, we get plus 1 into x is plus x, and plus 1 into minus 2 is minus 2. So now we have the correct numbers. So now we can take this x minus 2 as a common factor, and then we have x plus 1 as the remaining term. So we take x minus 2 as a common factor. So x minus 2 multiplies this x, so we have this x here, and the x minus 2 multiplies this plus 1, so we have the plus 1 here. So x minus 2 into x plus 1. So we can now write this whole thing as, so that's equal to x minus 1 into, so this quadratic polynomial is now factorized further into x minus 2 and x plus 1. So we have the entire factorized factors of the cubic polynomial as x minus 1 into x minus 2 into x plus 1. Okay, so these are the factors of our cubic polynomials. So you see, it's fairly straightforward. The first step is to find one of the zeros by trial, and once we have found the zeros, we perform synthetic division to get the second factor, which will be a quadratic polynomial. Then we subsequently factorize the quadratic polynomial further by any of the methods. Okay, we have used here the method of splitting the middle term. We could have used the factor theorem as well. Okay, so now we have all the factors of the given polynomial. X cubed minus 2x squared minus x plus 2 has factors x minus 1, x minus 2, and x plus 1. So the polynomial is a product of its factors. Okay, so it's this polynomial p of x is x minus 1 into x minus 2 into x plus 1. Okay, so let's do another problem from the exercise, the next problem from the exercise. So the second question from the exercise is p of x equals x cubed minus 3x squared minus 9x minus 5. So let us try to find the zero of the polynomial by trial. So let's see, let x equals 1. So in this case we will find p of 1, and that will be 1 cubed minus 3 into 1 square minus 9 into 1 minus 5. And does it give us 0? So that will be 1 cube is 1, minus 3 into 1 square is 1, so minus 3 into 1 is minus 3, minus 9, minus 5. So clearly this is not 0. Okay, this is minus 3 minus 9 is minus 12, minus 5 is minus 17, plus 1 is minus 16. So this is not equal to 0. So 1 is, x equal to 1 is not a 0 of the polynomial. So again we have to do, okay, generally start with 1. And if 1 does not work, then try minus 1, then try 2, then minus 2, and so on. So let now x equals, let's try minus 1. And we will find p of minus 1. So in this case, we'll have minus 1 cubed minus 3 into minus 1 square minus 9 into minus 1 minus 5. So let's see what we get. Minus 1 cubed is minus 1. Minus 1 square is plus 1, so minus 3 into plus 1 will give us minus 3, and minus 9 into minus 1 will be plus 9, and we have minus 5. So what do we get here? Minus 3 minus 1, minus 1 minus 3 is minus 4, and minus 4 minus 5 is minus 9, and then we have the plus 9. So minus 9 plus 9 is equal to 0. So x equal to minus 1 is a 0. So therefore x minus minus 1 is a factor. Okay, so x whatever is the number here, x minus that number is a factor. So x minus minus 1, which is basically x plus 1, is a factor of this p of x. Okay, the next step would be the synthetic division. So we will perform now synthetic division. So we will write the coefficients of the given polynomial. So the coefficient of x power 3 is 1. The coefficient of x power 2 or x square is minus 3. The coefficient of x is minus 9, and the constant term is minus 5. So we are going to divide this with the factor that we have found, which is x plus 1. So that corresponds to x equal to minus 1. So we are going to divide this with minus 1. And as usual, the first step is for the first term, below the first term, we'll write a 0 and add those two. 1 plus 0 is 1. And now we multiply this 1 with this minus 1 here. So 1 into minus 1 is going to be minus 1. So now minus 3 minus 1 is minus 4. And we now multiply this minus 4 with this minus 1. So minus 4 into minus 1 is going to give us plus 4. And minus 9 plus 4 is minus 5. Now the product of minus 5 and this minus 1 is minus 5 into minus 1, which is plus 5. And now the sum of minus 5 and plus 5 is 0. So now we can say that our polynomial p of x, okay, we can say that p of x equals x cubed minus 3x square minus 9x minus 5 is the product of its two factors. The first factor is x plus 1, and the second factor is this will correspond to x square minus 4x minus 5. So the second factor is x square minus 4x minus 5. Okay, so we have these two factors. Now the second factor is a quadratic polynomial, so we can factorize this further by splitting the middle term or by using the factor theorem, and eventually we'll have all the factors of the cubic polynomial. Okay, so let's continue with that on the next page. So now let us split this second part, the second factor, which is a quadratic polynomial, further into its own factors, and proceed with getting all the factors of our cubic polynomial. Okay, so we can split this further. So as usual, I'll just do it separately on the other side of the page. So we'll write x square minus 4x minus 5. We want to split the middle term such that the product is minus 5, because we have to get the product as the product of a and c. Okay, the coefficient of x square and the constant coefficient. So 1 into minus 5 is minus 5, and we need to get the sum as the middle term, which is minus 4. So what two numbers, if we multiply, will give us a product of 5, and when we add, it will give us a sum of minus 4. The product should be minus 5 and the sum should be minus 4. So to get 5, the only possible with the integers is 5 and 1. Okay, so we'll get 5 into 1 is 5, but we want a negative sign in front of that, so we have to make one of these as a negative number. So if we make the negative sign in front of the smaller number, which is 1, then we'll have 5 minus 1 as plus 4. 5 into minus 1 will be minus 5, but we'll end up with a sum of plus 4. So we want a minus 5 here as well as a minus 4 here. So we'll have to put the negative sign in front of the bigger number, which is 5. So it is negative 5. So negative 5 into positive 1 is negative 5. So minus 5 into 1 is minus 5. And minus 5 plus 1 is minus 4. So we can split the middle term based on these two numbers, minus 5 and plus 1. So we can write this as x square minus 5x plus 1x minus 5. And now we can simplify this further. So we can take x as a common factor and we'll have x minus 5 in the bracket. How? When we take x as a common factor out, so x multiplied with x will give us x squared. So we put x here. And we need a 5x as our second term. So minus 5 into x will give us minus 5x. Okay, so x into x minus 5. Now we replicate this x minus 5 again here. So x minus 5. And we will figure out what number should be outside this bracket to get the second half of this polynomial, which is x minus 5. So this is x minus 5 and we want x minus 5. So the term outside the bracket is going to be plus 1. So 1 into x minus 5 is x minus 5. So 1 into x is x and 1 into minus 5 is minus 5. So now we can take the x minus 5, which is the common term, and then we have the other term, which is x plus 1. Okay, so now we have the entire set of factors, which is x plus 1 into x minus 5 into x plus 1. Okay, so that's the entire set of factors. Or we can also write this as x plus 1 into x plus 1. I'm just writing the x plus 1 together, and then we have the third term, which is x minus 5. Okay, we can write it in any order because multiplying, changing the order of multiplication does not alter the result. So we have x plus 1 into x plus 1 into x minus 5. So basically what we see is that there are two zeros with the same value, x equal to, when we equate this to 0 and solve for x, we get x equal to minus 1, which is what we found by trial here. So we got x equal to minus 1. And then we have another 0 at the same position of x equal to minus 1. So because the degree is 3, there are 3 zeros. So we have the two zeros at the same position, which is x equal to minus 1, and one of the zeros is at 5, x equal to 5, right? So the factors of this cubic polynomial are x plus 1, x plus 1, and x minus 5. So which we can write as we can combine these two x plus 1s and write it as x plus 1 the whole square into x minus 5, but that is not necessary. Okay, we can leave it at this place. So the factors of this cubic polynomial are x plus 1, and x minus 5. Okay, let's do the third problem from the exercise. Alright, so our third question is p of x equals x cubed plus 13x squared plus 32x plus 20. And the first step, as usual, is to find a zero of the polynomial by trial. So we will have to just try. So let x equals minus 1 and see if we get the polynomial to evaluate to 0. So we'll get p of minus 1, which is minus 1 cube plus 13 into minus 1 square plus 32 into minus 1 plus 20. Let's see what we get. Minus 1 power 3 is minus 1. 13 into minus 1 square will be minus or plus 13, because minus 1 square is 1 and 13 into 1 is 13. 32 into minus 1 will give us minus 32 plus 20. So now what do we get for this? We have 20 and 13, so that's plus 33, and minus 1 and minus 32, that's minus 33. So minus 33 plus 33 equals 0. So x equal to minus 1 is indeed a zero of this polynomial. So we have x equal to minus 1 is a 0 of this polynomial. So therefore we can say that x minus 1, which is equal to x plus 1, is a factor of the given p of x. Okay, so once we have one factor, we can find the other factor by synthetic division. So again, when you start for checking the 0 of the polynomial, start with plus 1 or minus 1, and usually for your case, for your class, you will find a 0. The question will be such that there is a 0 at either plus 1 or minus 1 or plus 2 or minus 2. Somewhere close to 0 itself, you will have one of the values evaluating to 0. Okay, so we have found one of the factors. So now we will use synthetic division to find the other factor. Okay, so again, as usual, our synthetic division, we will take the coefficients of p of x. So the coefficients are 1, 13, 32, and 20. And we are going to divide this with our 0 that we have obtained, x equal to minus 1. So we'll put that minus 1 here. So now the first step is to put a 0 below the first term and add them. 1 plus 0 is 1, and then 1 into minus 1 will be minus 1. 13 minus 1 is 12, and 12 into minus 1 is minus 12. 32 minus 12 is 20, and 20 into minus 1 is minus 20. And when we add these, we get 0. Okay, so now what is left over is the coefficients of the second factor, which will be a quadratic polynomial, because our given polynomial is cubic. So these are coefficients of a polynomial whose degree will be 1 less than the given polynomial's degree. So this will be x squared plus 12x plus 20. Let me write the 20 properly. Plus 20. So now we can write our p of x as a product of its two factors. So p of x, which is x cubed plus 13x squared plus 32x plus 20, can be written in terms of its factors, which is x plus 1, into the second factor is x squared plus 12x plus 20. Okay, plus 20. Okay, so we have these two now. Now we can further factorize the quadratic polynomial to get all the factors with degree 1. Okay, so let's do that on the next page. Okay, so we have this cubic polynomial split into its two factors, x plus 1 and x squared plus 12x plus 20. We obtained x plus 1 by trial by finding the root of this polynomial. So that was our first step. We got x plus 1 as a factor. Then by performing synthetic division, we got the second factor. And now we have to factorize this second factor further, because it's a quadratic polynomial. We can factorize it further. So we will proceed with that process. So we have this term which we are going to factorize further. So we will write x squared plus 12x plus 20. So we need to split the middle term 12x such that the two numbers give us a product of 20. Because 1 into 20 is 20 and the sum is 12. So we need two numbers whose product is plus 20 and the sum is 12. So of course 20 we can write as 4 into 5, but 4 plus 5 is not 12. We can have 5 into 4 or 2 into 10 or 10 into 2. Okay, 2 and 10 looks feasible. So we can have, say, 10 into 2. So we now have a product 10 into 2 is 20 and 10 plus 2 is 12. Okay, it satisfies both the conditions. So we can split this middle term using 10 and 2. So we can write this as x squared plus 10x. So the 12x, we are splitting it as 10x and 2x plus 20. Okay, so this is separate. So now we can take x as a common factor. So x multiplied with what term will give us x square? X into x will give us x square, and then we need a plus 10x, so we put plus 10. So x into plus 10 will give us plus 10x, and now we replicate that x plus 10, and with what number? If you multiply this x plus 10, we should get 2x plus 20. So we need 2 here, so 2x, so we need to multiply with plus 2. So plus 2 into x will give us plus 2x, and plus 2 into 10 will give us plus 20. So now we can take the x plus 10 as a common factor, and then we have x plus 2, okay, which is x plus 2 here. Okay, so now we have split the quadratic part into its own factors. So we have x plus 1 into x plus 10 into x plus 2. So now we have all the factors of the cubic polynomial in terms of degree 1. Okay, x plus 1, x plus 10, and x plus 2. So that is the complete set of factors for our given polynomial. Okay, so now we have completed our problem. Okay, the factors of x cubed plus 13x squared plus 32x plus 20 are x plus 1, x plus 10, and x plus 2. Okay, so we have now represented our polynomial as a product of its factors, and that's the procedure to factorize cubic polynomials. So the first step that we have to do when factorizing cubic polynomials is to find one of the zeros of the polynomial by trial, and generally it is wiser to check for the zeros with smaller numbers like x equal to 1, x equal to minus 1. If it doesn't work, then try plus 2 and minus 2, then try plus 3 and minus 3. Usually you will find one of the zeros within this set of smaller numbers. So once you have found a zero of the polynomial, you will have one of the factors, and then you can find the second factor by synthetic division, and from the synthetic division you will get the second factor, which will be a quadratic polynomial, because we are factorizing a cubic polynomial. So the second factor will be a quadratic polynomial, and that quadratic polynomial can be factorized further by using either the factor theorem or by splitting the middle term. We have done consistently using the middle term, which is fairly straightforward. So once you have factorized the second quadratic polynomial as well, you will have the set of all the factors for the given cubic polynomial. Okay, so that brings us to the end of this class. There is one more problem in the exercise. I will leave that as a homework for you, and if you do have any issues with solving that problem, question number 4 for the cubic polynomials factorization, do leave a comment, and I will try to solve it and give some input regarding that. Okay, we'll stop here for now, and we will continue in our next lecture regarding polynomials, where we will be discussing about some algebraic identities and how to use the algebraic identities to solve polynomial expressions. Okay, we'll stop here and we'll continue with our discussion in the next video.